If you hook up a voltaic cell and you connect the wires together and you get a positive E cell reading, then that means that the reaction is spontaneous. The electrons spontaneously go from the anode to the cathode. If you hook up the cell and you get a negative reading, then that means it would be non-spontaneous. The reaction does not take place. And we know how to solve for E cell. It's always going to be reduction minus oxidation, or the cathode minus the anode. Okay, so is the following reaction spontaneous? Well, notice what happens. Barium goes from +2 to just barium. So that means that it gained 2 electrons. Pb goes from Pb to Pb plus 2, so that means it got oxidized. So I'm going to take my reduction, barium, minus my oxidation, lead, which is going to be negative 2.9 minus negative 0.73. Of course, I have to switch the signs there if I subtract a negative. And you get an answer of negative 2.77. Because it's a negative answer, it's non-spontaneous. This reaction does not take place. So, since I'm talking about spontaneity, there must be some sort of relationship between delta G and E. And this is what it is. Delta G equals negative NFE. E is the E cell. N is the number of electrons being transferred in the chemical equation. F is called Faraday's constant. Faraday's constant is the charge of 1 mole of electrons. If I have 1 mole of electrons, 6.02 times 10 to the 23rd electrons, it has a charge of 96,500 coulombs. And then don't forget that a volt is the same thing as joules per coulomb. So if I take joules per coulomb times coulombs per moles times the number of moles, I'll end up with joules. Just remember that delta G is not measured in joules, it's measured in kilojoules. So solve for delta G for this reaction right here. Well, the first thing we're going to do is write out the two half reactions. Okay? And then we're going to do reduction minus oxidation. Well, if you notice, this goes from Mn to Mn plus 2. The only way it can do that is by losing 2 electrons. So this is oxidized. Chromium is reduced. So I'm going to take my chromium value, negative 0.74, minus my oxidation value, negative 1.18, and I get 0.44. And I can tell you right now that's a positive value, therefore this is going to be spontaneous, therefore delta G should be negative. And so now we need to plug in everything into our equation. The number of electrons, if you look at the two half reactions, how many electrons are being transferred? The answer is 6. So delta G is going to equal negative 6 Faraday's constant, which is 96,500 coulombs, times 0.44 volts, but remember volts are joules per coulomb. Coulombs cancel, moles of electrons cancel, you end up with joules. Okay, it's negative 2,500, or excuse me, 250,000. That's in joules, so the answer is negative 250 kilojoules. And there's your negative telling you it's spontaneous. To solve for K, since there's a relationship between delta G and K, we're going to use this equation again. Delta G equals negative RT natural log K. Remember, this is 8.314 joules. So you can either put both of these in joules, like they do right here, joules and joules, or you could keep this negative 250, and don't forget you would call this 0.008314. Temperature is 25 degrees standard, and then solve for K, and you get a value of 6.6 times 10 to the 43rd, which is a freakishly large number, which means that equilibrium favors the right-hand side, because this reaction is spontaneous.